this is section B of 2023 examination 2. So let's get started. State the coordinates of all axial intercepts of F. So that one is actually straightforward. So that's going to be 0, negative 1. Alright, that's straightforward. So find the coordinates of the stationary point of F. So we just use our CAS. It's going to be f of x x times x minus 2 plus 2. So -3, 1. It's going to get the derivative of f of x, solve for x. Alright, so now we're just going to have to substitute back into our f of x. And x equals to that. And f. And that equals to that. So that's going to be, so we get this. Coordinate up there. Our other coordinate was the positive one. Yeah, so that's actually year 14. Yeah, that's right. Alright, that's done. So let's move on to the next part. Alright, let g of x find the values of f of x. So we're just going to have to equate the two. So g of x is the same as x minus 2. So menu 3, 1 f of x, g of x, solve for x. So those are the values of x. Alright, write down an expression for using definite integrals that gives the area of the region. So it's better to find out which one comes. So let's graph that. So control doc 2. So that's going to be f of x, tap g of x. So those are the three intersecting points. So this must be the negative one. That's the positive one. So this bit here, the f of x is the top. So g of x. Alright, so that's going to be, so expression for using area. The other bit g of x comes first, the top curve. Alright, that's how you do it. Then hence find the area of the regions bound by f and g to correct the two decimal places. So this bit there. Alright. Well, we could actually use this integral, that section but again, better we use integration. Just skip that. Alright, now I'm just going to use integration, much easier. Alright, this bit here. On the top was f of x minus g of x plus, I'm just going to copy this and make this one 2, make that negative, and make that one positive. And that was g of x. Alright, now that's f. Alright, we need correct 2 decimal places, so that's going to be 5.95. Alright, 5 point, well, the area is, well, roughly .95 units square. Alright, the next bit, find the possible values of a and b, well, in that format, where h of x is f of x plus k. So k is actually a translation, units up or down. So the distance that has been moved up there, well, that's basically the y. If it has been shifted down, so if you make it positive, whatever has been shifted down, so that's our k value. So our k value, well, the coordinates we had here was, what was it? So 7 plus 1 over 3 negative 14 square root of 7 minus 20 over 27. Well, that's okay, so we're just going to make it positive in order for this whole graph to sit there. So this is like shifting this whole graph and making it to sit up there. More of that. Oops. More of this. More of that. Alright, okay, so that's going to be my h of x. It's going to be f of x plus 14, 7 plus 20, oops, over 27. So we solve for this, alright. Alright, what's the value they're gonna be? 31 f of x plus, I think I already have that one. So this one here, we just make it the positive. That's gonna be positive. Solve for x, so that is my x value, and that's going to be, alright, if I solve for that, that gives me my x value has to be negative 2 square root 7 plus 1 over 3, or 7 square root of 7 plus 1 over 3. Yeah. Well, that's how it was. Oops, actually. Negative 2, yeah, so the negative plus a, so that's going to be that. Okay, over 3. So therefore, my a value has to be negative 2. So you multiply that by a negative. and my b value has to be square root 7 plus 1 over 3. Alright, that finishes question 1. Alright, let's move on. Question 2. Alright, the following diagram represents an observation wheel with its center at P. At point P, passengers are seated in pods which are carried around as the wheel turns, and the wheel moves anti-clockwise with a constant speed and completes one full rotation every 30 minutes. When a pod is at the lowest point of the wheel, point A, it is 15 meters above the ground. The wheel has a radius of 60 meters. Consider the function f of h of t. So show that b equals to that. So negative 60 cos p t plus c. So now the period, we already know the period is 30 minutes, it's been mentioned there. And so that is p equals to 2 pi over n. So my n value is the b. So that's going to be 2 pi over 30, which is pi on 15. Alright, now the c is the mean position, which is going to be the amplitude plus the 15. So that's going to be 60 plus 15, which is 75. Find the average height of a pod on the wheel as it travels from point A to point B. So point A is actually 0, 15. And point B will be half of that. So that's going to be 15. And we want to find out the average height. So that's going to be 1 over and 7.5. And minus 0, so h of t so it's going to be h of t. Let's define that, much easier to define it. So the negative 60 cos pi 15 times t plus 75. Alright, we've defined that. So now we need to 1 over 7.5 times the integration of that. So what's that? How many decimal places was that? 2 decimal places. Alright, that's 3680. Alright. The next bit, find the average rate of change in meters per minute of the height of a pod on the wheel as it travels from point A to point B. So that's going to be h of 77.5 minus h of 0, which is actually 15, over and 7.5 minus 0. Well, h of 0 is 15, so 75 minus 15, 7.5 right, meters per minute. Alright, now we know that h of t is that, so state the values of k and m. Well, at this point here, they are both the same when it's 15, so if I actually substitute that to 15, h of t, what do I get? Alright, h of t, 15, that's 135, so k is 135. And my m value is basically, so now after 15 minutes the wheel stops moving and remains stationary for 5 minutes. After this it continues moving at a double its previous speed for another 7.5 minutes. So now as it doubles, the period is actually halved. So that means the period was 30, so that means 2 pi. So this is a dilation factor, so that means pm equals to half of p, which gives me, when the speed is double, the period is halved. So that means 15, so that's 15, and we know that p was pi over that, so pi over 15 m equals to 2 pi. So 15 goes, pi goes, so m must be 2. Alright, the next one. Find all possible values of n. So now at this point here, they both have 20, so they must be the same. So at that point, they're the same. So m is 2, so we're just gonna have to go back to the CAS and say that we're just gonna have to use distance solve, many 3, 1. So 135 equals to h of t, well, h of t was defined it already, 2. Then at 20 they are the same, plus n, comma n. So n is that, which is, we said that 135, that's when they're the same. At 20, they're the same. One is 20 minutes. So h of t times 20 plus n, comma n. So my n value we obtained has to be 5, 6, n plus 1. N plus 1 is an element of z. Alright, so sketch the graph of the piecewise function of function w on the axis below, showing the coordinates of the endpoints. Alright, now we have to play around with this one here. So let's go back to the CAS. So menu doc, press the catalog to get this piecewise functions. Alright, now our piecewise function, our first one was h of t. Alright, actually we have to change t to x. Just define this because the calculator will not give any output, so I'm just going to make it x if we don't make it x. Alright, now let's go back. So the catalog, again the piecewise, h of t, h of x rather than t, and this one was alright, this one was 135 from 15 to 20. Alright, now we create slider. We can just change based on the graph we have. So we have, well, the highest point we have is actually 150 on the y-axis. So let's go back to, so we're just going to make that one 160. Let's click this 160. I'll make this one here has to be 0. I'll click this has to be 0 again. Just to make it look like the one we have. Alright, that's the other one. We have 25 as the highest. Or we can just do the Windows setting, to be honest. Let's actually make it 30. Alright, now let's play around and join it. Okay, that's joined. So we need to also include the endpoint, which is that point there, that point there. So let's actually go to actually down there, that point. We also need to get this point here. Yeah, that's my y-intercept. Also, the other point we need is that top they have there. Let's secure that. Alright, now that's 15. We got that. Oops. So that was 15. So up there, that was 0, 15. And our other point was 15. When it was 15, it's 135 somewhere here. Somewhere there. So my other point is actually when it's 20, it's also 130. So that's going to be a line. So that was about 5 minutes. It wasn't actually moving, so stationary. So now my last point is 27 and 15, which is somewhere here. 97, 15. All right, let's move on. 27.5 and 15, and that was 20, 135. That's 15, 135. And that's my piecewise function. All right, let's move on to the next question. So the next question is asking us consider the function g of x, 2 to the power of x plus c. So that's actually exponential function with, this is the horizontal asymptote. So as x goes towards the negative direction, well, the value will actually approach, well, it won't pass 5, so it's going to be 5. The derivative of that in this format here, so find the real value of k. So let's find out the derivative of that function. G of x. So that was 2 to the power of x. Alright, so that's going to be, oops. Alright, where k equals to the natural log of 2. Or now, find, let a be a real number. Find in terms of a the equation of the tangent of to g. So, well, we could use this formula here, which can be written as Well, that's my m value, so that's going to be y equals to the natural log of 2 times 2 to the power of a, x minus a, well, plus, and that's going to be my, what's that, g of s, 2 to the power of a, plus 5, alright. Hence, or otherwise, find the equation of the tangent to g that passes through the origin. Well, the origin x and y are the same, so they're both 0. So now, if I solve for that, so what do I get? So I want to get the value of a. Well, we want to get the value of a first. When y equals to 0, and x equals to 0 as well. Comma a. What do I get? Alright, then u3 1. Natural log. That's the wrong one. So 2 times 2 to the power of a, to bracket into bracket a, where x was 0, so minus a, and plus 2 to the power of a, plus 5 equals to 0, comma a. So what's that? So that gives us the value of a as to be that. So when I get the equation as to be, well, that's the a value. If that's my a value, so my g of x was my g of x. So if I substitute that back into my g of x, what do I get? What's that? Oops. So g of x, also g of x. Oh, it's 2g of x. Alright, let me just copy this. Should have cleared the history. Alright, let me get this one here. Get that. Get rid of the. Oh, that's what this one here. If I substitute back in that, what do I get? Alright, well that actually, so that's gonna be the a value. Alright, I have to get this equation here. This could be that. Alright, now this one was supposed to be x. Alright, and this is supposed to be a. It's supposed to substitute back in this equation. Here we go. And this one here. Alright, now so that means, well actually that's, well this is going to be only 0 anyway. So my y, well this is where we're supposed to be substituting after we find the y value. So that's going to be 3 decimal places, 4.255. Yeah, 5 x, and that's it. Alright, so find the coordinates of the point of inflection of a, so h of x, so that's h of x. So clear history, was under the h of x. Alright, now h of x such that h of x 2 to the power of x plus or minus x squared and I want to find out the point of intersection. Control that, h of x, so that's going to be the point of inflection. Menu, analyze point of inflection, which is 5, so that there. So that's my answer. So let's actually get that, the point of inflection, to 2 decimal places. So our answer is negative 0.75. Alright, find the largest interval of x values for which h is strictly decreasing. Alright, now I get that was the point of inflection. Well, it's actually decreasing in this section, the minimum and the maximum. Alright, this is the maximum point, and this is the point, the turning point. That's where it's actually decreasing. Alright, now this one here. So 0.49. And 3.21. Alright, apply Newton's method with initial value of 0, x is 0. Find the x-intercept of h, x1 and x2. Alright, so Newton formula was, it's always in the formula sheet, but on there. Alright, let's get the derivative of h of x. Alright, so if we say that's 0 and my h of x, well, before I do that, so if I get this, could be that, Control V, put 0 there, so whatever is left is natural log of 2, which is going to give me, so that's going to be 0 minus h of x when x is 0, so the natural log of 2, oops, alright, now, so that's going to be as a decimal, what that will be, so negative 44, negative 144, negative 1443. Alright, going to use that same answer. Well, it's going to be, I'm going to get this one again, Control C, Control V. We're going to put that value of x. Oops, what have I done? Must have done something wrong here. Alright, let me just do that one again. If I do that well, Control C and substitute. Well, can I actually define that as to be g of x? Why not? And I can just put it in there, much easier. I can define the function as a function, and I can just do this, 0 minus is to be h of x, and I get this answer. Put it in there, and I get g of x. Can I get this? Much easier when it's the handheld one. Alright, actually, what am I making a mistake on this? Just copy that. Control V. No, just to put a bracket, much easier. Alright, now, so that answer, what is that answer? That's that one there. Okay, now that answer minus that. What's this one here? I just get this one. Alright, and this answer there. Why this one didn't actually make sense. For the function h, explain why a solution to the equation and natural log of that times this minus 2x equals to 0 should not be used as initial estimate as 0, because the denominator will be 0, on which makes it to be undefined, and that's why I had to do it separate. Well, because the denominator will be 0, which makes it to be undefined. Alright, now there is a real number n for which the function h of x equals to that has a local minimum value on the x-axis. Find this value of n. Alright, so now if I get the derivative of this, what do I get? So the derivative of h of x, and I say that such that n to the power of x minus x to the power of n. So let's get the derivative of this, f of x. Oh, I think there is other actually. Calculator remembers the other f of x I used before. Let me just clear that and just make it something else. I'm just gonna make it and maybe d of x, because it looks like the calculator is remembering that. Alright, now n to the power of x minus x to the power of n. And I'm just gonna get the derivative of this, d of x. Same thing. Alright, now let's solve for that. And let's add menu action. To that, yeah. So it will give me the same answer. Alright, now let's do it again. That's better. So now, because alright, now let's solve this. Comma n, it's going to be comma n when x equals to 0, when x equals to n, when x equals to n, which is, well, that's going to be, well, that's going to be the same as e to the power of 1. So the value of n will be, after I solve this, when x equals to n, well, that's going to give me e. Alright, let's move on to the next one. Question is asking a manufacturer produces a table 10, so this is a probability question with a normal distribution D with a mean of that. So my normal distribution D to it all, my normal distribution, which is the mean, 6.7, 0.1 squared. All right, now so that's going to be menu 5, 3 when the probability is actually, I know it's a menu 5, 2. So now that's going to be, we're actually getting when it's greater than 6.8. So that's going to be, all right, if I actually get this, what do I get? And greater than 6.8, 6.7, 0.1, and that's going to be 1587. The probability that D is greater than 6.8 is 15.87. Find the minimum diameter of a tennis ball that's larger than, alright, that's larger than 90. So that's going to be inverse norm. So we're going to use the inverse norm. So menu 3, menu 5, 3, which is 0.9, and the mean was 6.7, 0.1, and that is going to be 6.83 centimeters. Alright, tennis balls are packed and sold in cylindrical containers. A tennis ball can fit through the opening at the top of the container if its diameter is less than 6.95. Find the probability that a randomly selected tennis ball can fit through the opening at the top of the container. So we're going to use binomial CDF, and it's actually the less than sign. Alright. Just going to copy this. Get this. Oops. Just going to menu 5, 2. So that's going to be, my lower bound would be negative infinity, 6.95. And the mean was 6.7. And the standard deviation was 0.1. And that gives me 0.9938. Alright. So this is going to be a random selection of 4 tennis balls. Find the probability that at least 3 can fit. So this is actually binomial question. So n is 4. That if they can fit, so the p-value must be, so this is our n value and the p-value must be 9938, because if they can fit, that's going to be the probability. So that's going to be, still use the CAS. So binomial question, this one is binomial CDF. So number of trials 4, probability of success 0.9938. The lower bound is 3, the upper bound is 4, and that gives me 3.98. Alright, let's move on to the next one. A tennis ball is actually tennis ball is classed as grade A if its diameter is between 6.54 and 6.86 centimeters. Otherwise, it's classed as grade B. Given that a tennis ball can fit through the opening at the top of the container, find the probability it's classed as grade A. Give your answer correct to 4 decimal places. So that's going to be, well, between 6. Whatever. Let's actually get this through. My pen. Oh yeah, here we go. Given that, it's actually less than that, so that's going to be a conditional function. All right. That's that. And we're just going to get this one here has to be there. My lower bound was 6.5, I think 6.54. And that in between there. And 6.86, and there it is. 89.60. The manufacturer would like to improve processes to ensure that more than 99 of the tennis balls produced are classed as group A, grade A, assuming that the mean diameter of the tennis ball remains the same. Find the required standard deviation. All right, so that's going to be the Z score. So it's going to be that. All right, now we need to find out the Z. So whatever is actually remaining is 1%. So divided by 2 in order to find the 2. So that's going to be 0.01 divided by 2, so that's going to be 0.005. So what's my Z value? Menu 553 0.005. So the negative 2.558 equals to 654 minus 6.7 divided by sigma, and that answer menu 35, that answer up there. Let's see, x, comma x, and that gives me 0.06. So standard deviation is 0.06. All right, now find an inspector takes a random sample of 32 tennis balls from the manufacturer and determines the confidence interval for the population of group grade A balls produced. The confidence interval is this. So find the level of confidence interval, the level of confidence that the population proportion of grade A balls is within the interval as percentage correct to the nearest integer. All right, now, so the p hat is that p1 minus p over n. Now that's, so the p value must be 382 plus 0.9493 divided by 2. So what I get? $84.3. All right, now let's find out our standard deviation, and we're just going to use the confidence interval. 535 is 1 minus 0.84 375 over my n value is 32. That gives us, well, oops. All right, we're just going to solve for that, the upper bound, the upper confidence. Z, we solve for Z. And 3, 1. Just get this. Then just multiply by Z and solve for Z. Z. Alright, so that's going to be the positive and the negative is going to be there. So Z equals to 1.644. So also the negative bit, so we're gonna have to also find the negative bit of it because it's symmetrical, and we're gonna use the, because we want to find out the probability or the percentage. So that's gonna be negative 1.6444 and 1.644, and that's going to be 90%. The probability of this is going to be, which is 90%. Alright, so now here, find the probability that having the speed of a grade A ball exceeds 50 meters. Alright, now, so this is going to be a grade A and grade B. So that's going to be grade A. So let's actually define this one here. It's a new function. F of V such that better. Alright, now V minus 30 over 3. Alright, we've defined that, so we want to find out the integration from 50 to 3 times pi squared plus 30 f of v, so it's that. Alright, now, so I want to find out f of v from 50 to 3 pi squared 30, which gives us 0.1345. All right, now find the expected mean. Where the mean is, we're going to multiply by v. So this whole, let's just get this down, times v. So we're going to make this one here 30. All right, so that's going to be 3 pi, where the mean is going to be 3 pi squared, what was it? Plus 4. Alright, the next bit here. A transformation maps the grade of f to the graph of g, where g of w equals, so let's actually define that one as well. So g of w is such that a times f w over b. All right, we've defined that. So what's the next bit of the information we have? All right, now if the mean speed for grade b of the ball is 2 pi squared plus 8 meters per second, find the values of a and b. So I want to find out. So we're just going to get system of equations, menu 371. So that's going to be a comma b. Alright, now we've got our system of equation. The first one is, it's a probability density function, so this whole lot should equal 2 and 1. So it's going to be, we can just copy this. Except that I don't need the v. Well, actually, no. The only downside is the function has changed. No, I can't do that. Alright, now so that's going to be 30b into bracket 3. But if I just copy that, g of x, g of w, and the whole thing equals to 1. And we're going to do the same thing here, but this time the mean with the mean. So we're just going to multiply this by w, and we're just going to make this one as to be, what was it, 2 pi squared so 2 pi squared plus 8 press enter. Alright, now this, just probably I left something, just have a look. It's gonna be this, make times in between. Alright, alright, now so that's going to be our a value. Our a value is 3/2. B value is 2/3. So it's just the reciprocal. Alright, question 5, the last question. Complete a possible sequence of transformations to map f to g. So that's going to be a dilation factor of 1/2 from the x-axis, where there is also a translation of 2 units. There's also a reflection if we just use the sequence of DRT, so the dilation as we mentioned. So a reflection in the x-axis because there's a negative in front of the x. In the y-axis, and also we have got a translation of 2 units x direction, 2 units x direction. All right, now two functions g and g of g1 and g2 are created both with the same rules as g of x with distinct domains. All right, now such that g1 is strictly increasing and g2 is strictly decreasing. Give the domain and the range of the inverse of g1. All right, now g1 is the same as that. So now if I define that function, let's create a history. All right, now f of x g of x all right, now we've defined that. What is the next thing you have to find out? I'm gonna find out that. Alright, now give the domain and the range of the inverse of g of x. So the inverse of g of x. Alright, now two functions g of x are created with both the same rule of g with distinct, such that g of 1 is strictly increasing, g of 2 is strictly decreasing. So if I get the turning point of g of x, what do I get? G of x, and I get the turning point. My turning point of g of x is 2 and 1. 2 and 1. Alright, now g of x turning point 2 and 1. So the inverse. So the x becomes the y. Where the y becomes x, domain of the inverse of g of x. So that's going to be, domain will be, well, 2, 1, I should say 1, positive infinity. And range will be 2, positive infinity. Alright. Find the coordinates of this. G of x is the same of that of y. So now the coordinates, well, this is going to be, alright, now we already have that drawing. So if I put x, y equals to x. Alright, now intersection, and the other intersection is 4.09. Alright, find the area region bounded by the graph and the inverse of. Alright, now if we find this area, so this is the area we actually, and that's the inverse. So this area, basically, that's the area we enter. So we after, where they are actually a mirror reflection of each other. So we could actually say the area from where we already have the points they intersect. So it's going to be 2.7, 4.0. Well, we're just going to multiply by 2 because it's symmetrical. So which one comes first? X comes first. X minus x, g of x. Alright, what's that's going to be? Alright, now back to the class. Well, if I go menu and I integrate that section from this section. Oops, can I get this one here? Just get that. Can I get area bounded, that area? Bounded area from that point to that point. That answer Control C, and I can just Control V this, can I? Times 2. Same thing. Okay. 5.56 units square. Alright, so now the turning point of H is always lies on the graph. F of, well, the turning point we already had as to be 2 and 1. So that turning point lies on this. Find the n, where n is integer. It's an integer. Find the value of n. So that's going to be the value of x is already 2, y is 1. So that's a half. Well, where actually y is 1, so that's going to be a half. It's going to be 2 to the power negative 1 equals 2. So that means n must be negative 1. Alright, now, what's the smallest value of k such that h will intersect h of 1? Well, it's basically the same graph. Same as what the one we had before. So actually the smallest k it intersected was 1.27. It's possible for the graphs h of x and the inverse of h of x of h of 1 to intersect twice. This occurs when k equals to 5. Find the area of the region bounded by the graph h and the inverse of h of 1, h1, where k equals to 5. Give you answer to 2 decimal places. Alright, now, so if that's equals to 1, and that's the other information we have, h1 is the same as y, which in this case, that 5 over 2, a half, 5 squared, x squared minus 4 plus 5. Alright, now, h of x, we had it before. Has to be, what was it? Oh, this one here, 1 over k, 1 over 5, f of x. Well, my f of x. So that's going to be 5 minus x. Alright, let's go back to the CAS. Alright, h of x is such that, alright, now h of x is going to be 1 over 5. Alright, h1 Alright, that one is actually the 5 was R. Alright, that's better. Alright, now find the area bounded by that. Alright, now, so we're going to find out the intersection of the two. Alright, now let's get to doc h of x and tab h1x. Alright, now let's get this one here. Analyze. Alright, now where they intersect. Alright, now trying to find the area. Our intersection points were this. Alright, now the edge of 1 actually comes to the top. Minus edge of x. And we can just go back to, we can just do this. Bounded area, which is 43.91. 43.91 units square approximate area, corrected to decimal places. And that is the last bit of the exam, the last question of the exam.